Hi, my name is Nat Tuck, and this is my demo video for Homework 1. As you can see, this is a clean startup of the simulation environment for the homework. The robot is in the starting position, and now we're going to go ahead and start the control program. So we'll run the control program, and now the robot is moving forward. Now the strategy that the control program uses here is that it's going to attempt to drive forward towards the goal until it sees an obstacle directly in front of it. When it sees an obstacle directly in front of it, it's going to turn right. And it uses a sort of broad definition of directly in front of it so as to avoid stuff. It uses a relatively wide angle for that purpose. So it turned right to get around this fire hydrant, and once it had gotten past the fire hydrant, so the fire hydrant was no longer in front of it, it went ahead and started driving, steering back towards the goal position. Then saw this fire hydrant, which it decided was in front of it, so it turned right to try to avoid it, and now it's turning right to do that. We can see here, oh, we missed it, but as it gets up to the wall here, we'll be able to see that it alternates back and forth pretty quickly between steering back left towards the goal and steering right to try to get around the obstacle. Here we can see it steering back and forth really quick. That's not necessarily realistic for a physical robot. We could put in some sort of damping to try to prevent it from doing steering corrections quite that quickly. That should probably be in the simulation rather than necessarily in the control program. Although the control program should also try to take sort of smooth actions, but we were able to get around that wall. So now there's no obstacle that's sort of immediately in front of the robot. So it's steering back in the direction of the goal point in order to try to get there. The next thing that it's going to run into is this wall here, which is going to be a little bit of a complication because its only way to turn is to steer right. And, I mean, steering left would get around this obstacle quicker, but that would also make the control program more complicated. So it's steering right here until the obstacle isn't in front of it anymore. And once it no longer sees the obstacle in front of it because it's steered far enough right, it's going to steer left to try to get back to pointing at the target, and it's just going to alternate steering left and right, and it turns out that the way this is tuned is good enough that it does manage to cleanly make it around that wall. Again, the side of the wall still shows up as an obstacle that's in front of it if it gets too close, but then eventually it clears the wall, and now it has a nice straight shot towards the goal. From here, it's a nice clean shot of just steering towards the goal and driving in that direction. So in order to find the obstacles, it's using the laser sensor, and there's some range of angles in front of it that it considers to be objects in front of it. There's some limited distance. I think it looks 2 meters in front of it in a relatively wide angle to find an obstacle in front of it. And then in order to figure out how to get to the goal, it's going to use its pose sensor. Now the pose sensor is sort of magical cheating. You can't really, in a real robot, have it know its pose exactly in the way we can in the simulation, but for Homework 1, having a magical perfect pose sensor that gives it its actual simulation coordinates is good enough for doing obstacle avoidance towards this goal. Under drive, it uses the actuators of speed and wheel turn, and then you can see we've gotten to the goal. The robot is entirely on the checkerboard. It declares victory. We can see we win here, and we have successfully completed Homework 1 with this control program.